it felt like an eternity, because each time the rope went up to get one of the survivors with it, it would disappear, and you'd think for a while that they'd forgotten about us, lost us, and we waited for ages. I don't know how many it'd take, maybe 6 or 10 rescuers to pull one person out.
Harry Bispham was one of the last to struggle out.
I then could feel a gentle breeze in the evening, and it was freezing. And I was better off actually being inside of the ship. But also, of course, I had to make my way along the full length of this ship, and I walked along the full length of Townsend Torrison, almost like a crazy zebra crossing.
Let it go. Over.
400 survivors were taken ashore, but the death toll was rising. By morning, still no one knew how many were missing. There was no passenger list. Only when the ship was righted could the corpses be counted. 193 people had died, 38 of them crew.
38 funerals was a lot to attend in a month, and I just felt I had to do it. I don't know why I felt I wanted to go to every funeral, but I just did. I just needed to know that they had been laid to rest and had finally got off of there. Because some of those, 4 of those, I used to take to work in my car. And when I went back to work the first time afterwards, it was empty, apart from me, and it was a really strange feeling.
The survivors and the families of the dead all wanted to know what happened. How could it have happened?
We went from safe to sunk in 90 seconds. So there's got to be something wrong there. With a big ship like that, 90 seconds. There's got to be something very wrong with the design of the ship.
What was wrong was there for all to see. A television camera had captured the gaping mouth of the ship. Her bow doors were wide open. Amazingly, it was a common practice. Because of the pressure on ferries to turn around quickly, captains routinely left port with the bow doors open. They were closed as the ship headed out to sea. But on the Herald, the man in charge of the doors was fast asleep. On the bridge, no one knew the Herald was a death trap, and the killer was a fatal flaw.
Mayday, mayday, mayday.
The disaster aboard the ferry Herald of Free Enterprise tragically had been foretold. At the inquiry, investigators uncovered several internal company memos from captains asking for a light on the bridge to warn them if the bow doors were open. In response, one company official scrawled, "Do they need an indicator to tell them that the deck's doorkeeper is awake and sober?" The inquiry pointed the finger at the man who had fallen asleep on duty, but also the company that operated the ferry. When it was all over, a wider issue remained unresolved: the vulnerability of roll-on, roll-off ferries to capsizing. A warning from history had come 2 decades earlier, on January 31st, 1953, when the British ferry Princess Victoria, en route from Scotland to Northern Ireland, sank. Out of 182 passengers and crew, 139 died. From then on, around the world, ferries continued to capsize at the rate of 1 a year. The Princess Victoria's stern doors had given way in a storm, but the Herald of Free Enterprise had sunk on a calm night in shallow, protected waters. How could she possibly have capsized? To find out, investigators built a scale model of the ferry, identical in every essential detail, and tested it with the bow doors open. Results indicated a phenomenon that no one had suspected.
We'd found in our model tests that there appeared to be a so-called critical speed, that if you were just below that critical speed, the bow wave on the Herald's type of bow rolled forward and rolled clear of the deck. If you went just slightly above that speed, and it only needed a quarter of a knot or something like that, then water would begin to move back onto the deck and in amongst the vehicles, slowly at first. But as the speed increased, there was this very sudden and very dramatic change where the deck was essentially engulfed as vast quantities of water went on very, very quickly.
Investigators thought the critical speed was 17.5 knots. Above that, the bow wave would be high enough to reach the car deck and pour into the ship. To test their theory, a full-scale experiment was conducted in Belgium with the Herald's sister ship, the Pride of Free Enterprise. Everything was the same, from sea conditions to loading to the trim of the ship. Everything except the bow doors. This time they were shut. Cameras were placed at key positions to record what happened. One camera was on the nose of the ferry as she gathered speed.
Looking down on the bow fender, which was known as the bow spade, and the bow doors, with the centre of the bow doors down here. There's some light spray coming over the spade at the moment, but most of the bow wave is being deflected forward by the shape of the bow. The speed is around about 14 knots.
As the ship's speed increases, the bow wave grows, eventually reaching the level of the doors. If the doors were open, the spray from the bow wave would be falling on the car deck.
Now getting up to 17 knots, where we're getting close to the critical speed, and there's much more solid water coming over most of the time, well above the handrail, and in many cases very nearly to the top of the doors. The speed is now above the critical. It's almost continuous white water coming over the forward spade now, and in the Herald itself a lot will be coming through the bow doors and entering the vehicle deck in considerable quantities. Well, at this point there would be massive amounts of water coming on board to the Herald. It would be cascading aft.
Investigators now knew how the water had gotten onto the car deck. The Herald, with its bow doors open, was thought to be proceeding at 18 knots, just above its critical speed. Just 1 knot slower, and the tragedy never would have happened. Now, only one question remained. How could water on the car deck sink such a large ship so quickly?
When you get water on the car deck, you are susceptible to a phenomenon known as, in naval architecture, as free surface effect, which is the same as saying the stability is reduced. An example of the problem of this water sloshing is if you try and carry a tray of water around and keep it steady. It's almost impossible to do, and you can feel the way the water moves backwards and forwards and makes the whole tray and water combination a very unstable device.
Just as the investigation was winding down, a freak accident dramatized the danger of a small amount of water slopping around a car deck. One evening in September 1987, the British car ferry St. Christopher was crossing the English Channel in a storm. Within minutes of its departure, the ship lurched violently. Passengers and objects were tossed from side to side. A large truck had turned over, crushing cars and shifting cargo. As a result, the bow doors had burst open. Several inches of water had poured onto the car deck, rolling the ship from side to side as it sloshed around.